Hey guys, Mr. G here. In this video, we're going to take a look at evaluating angle measurements on a unit circle. Now, when evaluating a trig function of an angle measurement, we got to ask ourselves these four essential questions. The first question is, which quadrant does the angle measurement theta lie on? The second question is, what is the reference angle of theta? The third question is, what is sine, cosine, or tangent of the reference angle? Now, if you guys recall, in the previous video, we talked about how to find a reference angle in each quadrant. All right? And the last question is, and this is one that is the most important, is sine, cosine, or tangent of theta positive or negative? Now, the placement that the position that theta is in plays an important role to answer the fourth question to determine whether the output is going to be a positive or a negative. All right. Now we're going to take a look at a few examples of evaluating some degree measurements. But before that, let's take a look at the unit circle that I wrote up. All right. So in this unit circle, I labeled out all of the degrees from 0 to 360. However, the angle measurements in the first quadrant are more detailed, which has the radians and the x and y coordinates. So what we're going to do as we're evaluating each trig function of an angle measurement, we're going to do a copy and paste format by using one of these x and y coordinates. So what I mean by a copy and paste format, let's say, for example, we're looking at the angle measurement, let's say 135. So when we find the reference angle for 135, if we were to get one of these angle measurements, 30, 45, or 60, what we're going to do is we're going to take the x and y coordinate from that angle measurement. We're going to copy it and then paste it into the format. So we're going to copy one of these x and y coordinates, and then we're going to paste it into the position of that angle. All right, so let's take a look at the first example. Now for the first example, we have sine of 240. All right, so for sine of 240, all right, we got to ask ourselves, which quadrant does 240 lie on? All right, so what I'm going to do first is rewrite sine of 240. All right, so then the first question is, which quadrant does 240 lie on? So if we take a look at my unit circle, we see that 240 is in between 180 and 270, which is the third quadrant. So for my first question, 240 is in quadrant 3. All right, so then we have the second question. So the second question is, what is the reference angle of 240? So now that we know that 240 is in the third quadrant and it passes 180 degrees, what I can do is I can take 240 and subtract it to 180 degrees. So once I subtract those two numbers, my reference angle is 60 degrees. So the reference angle for number 2 is 60 degrees. So now that we know that the reference angle for 240 is 60, what we can do is we can evaluate sine of 60 degrees. So sine of 240 is going to be similar to evaluating sine of 60 degrees. But they're not going to be exactly the same thing. And the reason for that is maybe the signs might be different. One is a positive, either they may be a positive output or a negative output. So since we know that the reference angle for 240 is 60 degrees, I'm going to use a copy and paste format. So I have this x and y coordinate for 60 degrees. So I'm going to copy that and then paste it where 240 is at, which is over here. So I'm going to write my x and y coordinate over here. So we have 1/2, comma, √3 over 2. So we have my X and Y coordinate for 240. Now, we also got to figure out, are one of these numbers or both of the numbers going to change into a positive and change into a negative value? Now, if you take a look at the placement, which is in the third quadrant, we see that the x-axis is on the left direction, which is a negative, and for my y-axis is going in a downward direction. So both of these are going to be negative outputs, negative x and y coordinates. So now we can go ahead and evaluate sine of 60 degrees. Now, sine of 60 degrees, when we're looking at sine, we either just take a look at the x or y coordinate. So let me just go ahead and write this down. So when evaluating a trig function for theta, we just either take a look at the x coordinate or y coordinate. Now, if you guys recall, to figure out cosine of theta, we look at the x coordinate. When we have to evaluate sine of theta, we look at the y coordinate. And since we're evaluating sine of 240, we're just going to take a look at the y coordinate, which is root 3 over 2. So sine of 60 degrees is going to be root 3 over 2. Now, if we take a look at where 240 is at, we see that it's in the third quadrant and both x and y coordinates are negative. So that means that sine of 240 is going to give me a negative output. So sine of 240 is definitely the same thing as evaluating the negative sine of 60. So then my fourth question would be a negative value. So if I were to evaluate sine of 60, I get root 3 over 2, but I have a negative in the front. So for my final answer, sine of 240 equals to negative root 3 over 2. So that would be my final answer. Okay? So that's what we're doing for each of when we're evaluating a trig function of theta. All right? So I'm going to do the same technique for the second example, which is cosine of 330 degrees. So now we're taking a look at 330 degrees. So for my first question, I got to ask myself, where's 330 degrees located in? If you take a look in the unit circle, we see that 330 is in between 270 and 360, which is in the fourth quadrant. So for example 2, I'm in the fourth quadrant, so quadrant 4. All right, so I'm in the fourth quadrant with 330 degrees. So now I need to figure out what is my reference angle for 330 degrees. So I'm going to take out my calculator, and we see that 330 is getting closer to 360 degrees. So I'm going to take 360 and subtract it to 330. So with that, I get 30 degrees. So my reference angle for 330 degrees is 30 degrees. So evaluating cosine is equivalent to evaluating cosine of 30 degrees. Well, in this case, similar. All right, so we got to figure out if the outcome for cosine of 330 is going to be a positive output or a negative output. All right, so since my reference angle for 330 degrees is 30 degrees, I'm going to take my x and y coordinate for 30 degrees, I'm going to copy it, and then I'm going to paste it to the same position where 330 degrees is at. So I have root 3 over 2, comma 1/2. All right, so now I got to figure out if both of the values are going to be negative or one of them is going to be a negative. Now, if you take a look at the position in the fourth quadrant, we see that we're on the right side of the x-axis, which is a positive direction. However, we are looking at a downward direction for my y-axis. So the only thing that's going to be a negative is my y coordinate. All right? So now we can go ahead and evaluate cosine of 30 degrees. So if we do cosine of 30 degrees, we just look at the x coordinate, which is √3/2. All right, so now that we evaluated cosine of 30, we evaluated the cosine of the reference angle, now we just need to figure out, is my output for cosine of 330 going to be a positive output or a negative output? And when we did the copy and paste format and then change one of the signs to be a negative, we saw that one of them stayed as a positive. Now when we're evaluating cosine of an angle measurement, we just look at the x coordinate. So for my x coordinate, it is a positive √3/2. So my final outcome is going to be a positive. So that means that these two are actually exactly the same. So if I were to evaluate cosine of 330, I actually get positive √3/2. All right? So that would be my final answer. Okay, so now let's take a look at two examples where we're evaluating tangent of a given angle measurement. So for example 3, we have tangent of 135. So what I'm going to do is I'm going to figure out which quadrant 135 is in. And it's in quadrant 2. So we see that 135 is in quadrant 2. All right. So now we get to figure out the reference angle for 135 degrees. And we see that 135 degrees is approaching to 180 degrees. Now remember, when we're referring to reference angles, the reference angle is created by the terminal side of theta of the angle measurement and the nearest part of the x-axis. Not the y-axis, but the x-axis. All right? So I'm going to take my calculator and I'm going to evaluate my reference angle. So I have 180 and I'm going to subtract that to 135. I get 45 degrees. So my reference angle for 135 degrees is 45 degrees. All right. So now what I'm going to do is I'm going to do the copy and paste format. I have my x and y coordinate over here for 45 degrees. So I'm going to copy it and paste it to 135. So I have √2/2 comma √2/2. So it's in the same spot as 135 degrees. But now we're going to figure out if both of the x and y coordinates are going to turn into a negative, or if only one of the numbers are going to turn into a negative. If we take a look at quadrant 2, we see that we're looking at the left side of the x-axis, which is a negative direction. So this one is going to turn into a negative, but this is going to stay as a positive since my y value we're looking in an upward direction. All right. So now for tangent, when evaluating tangent of an angle measurement, what we do is we take the x and y coordinates and divide them to each other. All right? So what that means is that I take my y value and divide it by the x coordinate. So I have √2/2 divided by negative √2/2. So if I'm dividing those two same x and y coordinates, so I have √2, let me use it in another color. So I have √2/2 divided by negative √2/2. All right? So if I'm dividing the same x and y value, if I'm dividing the same numbers, then what do I get as my outcome? If you guys said 1, then you're absolutely right. So what that means is that if I divide these two numbers, I get 1. Now we have one that's a negative, so my outcome is going to be a negative. My outcome is going to be a -1. However, the negative one is for 135. I'm still evaluating the reference angle, so both of them should be a positive. So we have both of them being positive is going to turn into a 1. But my final answer is going to be a negative output, because since I'm dividing one positive by one negative output, I'm going to get a negative. So we have tan of 135 degrees equals to a negative 1. All right? All right, so let's take a look at the fourth example where we have tan of 210 degrees. Now 210, we see that 210 is in between 180 and 270, which is in the third quadrant. All right, so for my first part, we're looking at quadrant 3. Now my second question, I got to figure out what is the reference angle of 210 degrees. So since we're in the third quadrant, what I'm going to do is I'm going to take 210 degrees and subtract it to 180, and I get 30 degrees. So my reference angle for 210 is 30 degrees. So now what I can do is I can use a copy and paste format for my 30 degree angle measurement. So I'm going to take this X and Y coordinate and copy and paste it to the same spot as 210 degrees. So I have over here root 3 over 2 comma 1/2. Now since the third quadrant, we're looking at the left side of the x-axis and the downward direction on the y-axis. Both x and y values are going to be negative. All right. So now what I can do is I can evaluate cosine tangent of 210 degrees. Now evaluating 210 degrees is similar to evaluating tangent of 30 degrees. All right. So what I'm going to do is for my tangent, So I have tangent of 30 degrees. I'm just going to take my y coordinate and divide it by the x coordinate. So I have 1/2 divided by root 3 over 2. Remember, we're dividing the y coordinate by the x coordinate. All right. Now, since unfortunately these two are not the same number, so what we're going to do is we're going to actually have to divide these two numbers out, but we're dividing fractions. So since we're dividing fractions, I'm going to do the keep, change, flip technique. I keep this fraction the way it is. I change the division into a multiplication, and I flip this fraction as 2 over root 3. Now what I can do is I can cross simplify the 2's, and then I just get 1 for each of them. And now what I can do is multiply the two numbers in the top. So 2 numbers on the top and the bottom. So I have 1 times 1, which is 1, and 1 times root 3, which is root 3. Now remember, when getting our final answer, we can't have a radical in the denominator. Remember, no tens in the basement. So what I'm going to do is I'm going to rationalize the denominator by multiplying both numerator and denominator by root 3 over root 3. And when I evaluate this, I should get root 3 over 3. So tan of 30 is going to be root 3 over 3. All right. Now, if you take a look at 210 degrees, both of them are negative values. So if I divide double negatives, my outcome is going to turn into a positive. So tan of 210 is actually the same thing as evaluating tan of 30 degrees. All right. So So I'm gonna figure out space to put my answer. All right, so I'm gonna put it over here. So tan of 210 it equals to root 3 over 3. All right. So we looked at angle measurements in between 0 degrees to 360 degrees. Now what we're going to do is we're going to take a look at other examples where we're going above the range. And we call those coterminal angles. All right. So now what we're going to do is we're going to evaluate trig functions for angle measurements that are out of the range from 0 to 360 degrees, whether they're negative values or positive values that are way above 360 degrees. All right. Now before that, I want to take a look at coterminal angles. Now with coterminal angles, we refer to angles as coterminal if they share the same spot in the unit circle, meaning if they share the same terminal side of the angle measurement of the angle. So what we're going to do is we're going to figure out, well, what is the angle measurement that is coterminal to the given angle measurement, and it has to be in between 0 to 360 degrees. So depending on what we're given, we're either going to add to 360 or subtract to 360 to get our angle measurement in between those 2 degrees. So start with example 1, which is negative 225 degrees. So what we're going to do is we have a angle measurement that's way below 0 degrees. And we need to get that back up to a degree that's in between 0 to 360. So should we add to negative 225 to 360 or subtract? If you guys said add, then you're absolutely right. So what I'm going to do is I'm going to take out my calculator, and I have negative 225, and I'm going to add that to 360 degrees. Now when I get that, I get 135, and 135 is in between 0 to 360 degrees. So we're good on that. So now what I'm going to do is I'm going to rewrite sine of negative 225 degrees is equals to sine of 135 degrees. So now we're able to evaluate sine of 135 degrees. It looks like one of the previous examples that we did when using the unit circle. All right, so now the first step is we got to figure out where is 135 located in the unit circle. And if you take a look at the unit circle, it's in between 90 and 180, which is in the second quadrant. So we're looking in the second quadrant. All right. So I'm going to rewrite sine of 135 equals to sine of a reference angle that we're going to figure out. So we know it's in the second quadrant. So what I'm going to do is I'm going to take 180 degrees. Let me put the calculator over here. And subtract it to 135. I get 45 degrees. So my reference angle for 135 is 45 degrees. All right. So we're looking in the second quadrant, and my reference angle is 45 degrees. All right. So now we're looking in 135 degrees, and luckily we already did a copy and paste format for the X and Y coordinate for 135 to the 45 X and Y coordinate for 45 degrees. So we don't have to do that again. All right. So now I need to figure out what is sine of 45 degrees, or in this case, what is sine of 135 degrees. Now, sine of 45 degrees is going to be my y-coordinate, which is root 2 over 2. And if we take a look at over here where 135 is at, we see that my y-coordinate is also positive. So sine of 45 degrees is root 2 over 2. And luckily, over here, my y-coordinate is a positive. So 135 degrees is equivalent to positive sine of 45 degrees. All right, now if we recall, 135 degrees and negative 225 degrees are also coterminal angles. So that means that since we have sine of 45 degrees as root 2 over 2, that also equals to 135 degrees, which also equals to negative 225 degrees. So for my final answer, sine of negative 225 degrees is equal to root 2 over 2. All right, let me box that up. Okay. So we're going to do the same exact steps for the rest of the examples with example 6. Now, example 6, we have sine of 450. Now, we have a degree that's above 360 degrees. So we need to bring that back down into a degree that's in between 0 to 360. If you guys said subtracting 450 to 360, then you're absolutely right. So we have 450 degrees. Subtract that to 360, I get 90 degrees. So I actually get a quadrantal angle measurement. So sine of 450 degrees is exactly the same thing as evaluating sine of 90 degrees. Remember, these two are coterminal angles. They share the same exact terminal side. All right, so now what I'm going to do is I'm going to evaluate sine of 90 degrees. All right, so now we're evaluating a quadrantal angle measurement. So we see that 90 is over here, and my x and y coordinate for 90 degrees would be 0, 1. Because if we take a look, we see that we're going 1 unit up. So that is a vertical direction and it's a positive direction. So we have 0, 1. So sine of 90 is my y value for 90 degrees, which is 1. So sine of 90, which is also sine of 450, is 1. So sine of 450 degrees equals to 1. And that's my final answer. All right, the quadrantal angle measurements, they're easy to evaluate since our x and y value are just 0 and 1, or vice versa. All right, so now let's take a look at example 7 and example 8. Now, example 7, we have an angle measurement that's way above 360 degrees. So we're going to have to subtract that. But we're not just going to subtract it once. We may need to subtract it multiple times. All right, so let's take a look. So we have 1,050. Subtract that to 360. I get 690. Still above the range. So I'm going to subtract again. So I subtracted twice. I get 330. So now I got an angle measurement that is coterminal to 1,050. All right, so we have cosine of 1,050 is the same thing as cosine of 330 degrees. All right, so now I can go ahead and evaluate cosine of 330 degrees. Now what I'm going to do is I'm going to figure out what is my reference angle for 330 degrees. So we see that 330 degrees is in the 4th quadrant. So I'm going to take 360 and subtract it to 330, and I get 30 degrees. So cosine of 330 is similar to evaluating to cosine of 30 degrees. Now, it may be the exact same or not, depending on what the sign of the output is going to be. So we have cosine of 30 degrees, and luckily we already did the copy and paste format for the x and y coordinate for 330 degrees. So my cosine, which is the x coordinate for this point, is root 3 over 2, and it's a positive value. So luckily, cosine of 330 degrees is equal to a positive cosine of 30 degrees, which also equals to cosine of 1,050 degrees. All right? So we have the cosine of 1,050 degrees. That's going to equal to root 3 over 2. And that's my final answer. All right. So now we're going to take a look at the final example, which is tangent of negative 420. So we have an angle measurement that's way below 0. So to bring it back up, we're going to add that to 360. And I get negative 60 degrees, still below that. So I'm going to add that again to 360 degrees. So we're adding twice, and I get 300 degrees. All right. So I have tan of negative 420 degrees is equals to tan of 300 degrees. All right. I didn't need to put parentheses there, but that's okay. All right. So we have tan of 300 degrees, and it is in the fourth quadrant. So we're looking at the fourth quadrant, and we see that 300 degrees, to figure out my reference angle, I'm going to take 360 and subtract it to 300. I get 60 degrees. So tan of 30 degrees is similar to evaluating tan of 60 degrees. All right? So we don't have our x and y coordinate for 330 degrees. So I'm going to use a copy and paste format. I'm going to copy the x and y coordinate for 60 degrees and paste it into this spot. So I have 1/2 comma root 3 over 2. All right. Now, if we're looking in the fourth quadrant, the x value is going to be a positive, but my y value is going to be a negative. So 1/2 stays as a positive, but this becomes a negative. All right. So now what we're doing is we're going to be dividing these two numbers. All right. So for tan of 300, we divide this value to this value. All right. So we have tan of 300, which is negative root 3 over 2 divided by 1/2. Now, since we're dividing two different fractions, I'm going to go ahead and do the keep, change, flip technique. Cross simplify. They both become a 1. Multiply the numbers straight through. So I have negative root 3 times 1. I get a negative root 3. And then 1 times 1, which is 1. And any number over 1 is the number itself. So tan of 300, or in this case, tan of negative 420, is negative root 3. All right. All right, so we have looked at all examples where we evaluate a trig function of an angle measurement, whether it is in between 0 to 360 or away from the range. All right. Hope you guys have a wonderful day.